Yes, so the application of this is not going to be immediately apparent. What we're going to do instead is we're going to crunch some numbers, and then later on, once we've got these skills, then the reason we're doing that, we'll sort of understand why we're doing that a bit later on. So these are the three formulas we're using here, and we're saying y is going to be some random variable that possesses some sort of linear relationship with x. Okay, we're using, remember, x denotes some discrete random variable, whatever it might be, spinning a spinner, rolling a dice. Y is some variable that bears a linear relationship to it. If that's the case, then the relationship between e of y, the variance of y, and the standard deviation of y is expressed here. The only thing that's new to you, perhaps, unless you've done spec last year, is this symbol here. Okay, so where we've got the two lines around A, that just means the modulus of A. And how big is it? What's the number? What's the size of it? So we've got this here. X is some discrete random variable, has a mean of 3.6 and a standard deviation of 1.2. First, we've got to find e of y. Well, e of y is equal to A times e of x. Now, I didn't write down the relationship between y and x. Y equals 2x take 3. Okay, so from here we can identify that's the value of A and that's the value of B. A is 2 and B is minus 3. So e of y will be 2 times e of x. Okay, e of x means the mean of x. It's the expected value. So remember, mean and e of x, they mean the same thing. So it's 2 times 3.6 and then plus b. B is minus 3, so we have take 3. So we'll have 7.2. We'll have 4.2. Okay, so without even having a distribution for y, we haven't drawn its distribution, but we do know it bears the linear relationship to x, and so that's going to be the expected value for this discrete variable y. Okay, so what have we done? All we've done is crunch a number. It means nothing to us yet. Okay? Standard deviation of y, we're going to use this one here. It's the modulus of a. So let's just talk about that. If I have the modulus of 2, it just means how big is that number? It's 2. Okay? If I have the modulus of minus 5, that means how big is that number? It's just 5. Okay? All it means is if it's negative, you make it positive. If it's positive, you leave it as is. So standard deviation of y, we need 5, and then times the standard deviation of x. 5 times 1.2. We've got 6.
Then you need to decide how you're going to tell that story in the
Okay. And then last one, the variance of y is a squared times the variance of x. So that's going to be 2 squared times. Now the variance of x, we're not told the variance of x here, but in the last lesson we said the relationship between standard deviation and variance. Standard deviation is the square root of your variance, and variance is the standard deviation squared. Okay? So we don't need to explicitly isolate the variance, we can just create it from the standard deviation here. Times 1.2 squared. Okay? We'll evaluate that.
That is an editable MP3 maker, quite high quality, and the advantage of that is once you actually
good point. You're correct. The modulus of A is 2. Thank you. 2.4.
You would cut that up.
A is 2. Yep. So it's modulus of A times standard deviation of x. Modulus of A is 2. Yeah. Good. Thank you for correcting me there. And last one here, what was that? So 4 times 1.44. We'll chuck these texts because they're no good already. 5.76.
Okay, it's all about levels, timings, all that sort of stuff.
Okay, so we don't have a purpose for it yet, but perhaps particularly later in this exercise, it should be unveiled. So that's it for 7E. Let's get into it. We will have some time to finish D. And there's another example, guys. So here's an application of the example. Look, I might not do it now because I think there's too much noise. So I'll just. So, just the first two parts we're pretty familiar with, but let's read through the example. It says Sherlock's a detective, makes $10,000 a month, and then every case that he solves, every crime, he gets an extra $2,000. And so sometimes he might solve 0, sometimes he might solve 1, 2, 3 or 4 cases is the most he's ever solved. And then there's a probability of solving that many cases there, okay? So the most common, here we went and found K, because sum of all probabilities is 1. The most common is 2. He normally solves 2 cases per month. So part A says find K, part B says find E of X and explain its meaning. So I found E of X here, and this is the average amount of cases he will solve per month, or expected number of cases per month. Okay. Part C says, let Y be the amount of money he earns in a month. Express Y in terms of X. Well, we know he's going to make $10,000 plus $2,000 for every case that he solves. And the variable for the number of cases he solves is X. Okay, so then to find E of Y, okay, so let Y be the amount, express Y in terms of X, that's done, that's our equation for Y. Then to find E of Y, we're just going to use that first equation that we developed over here. We've got E of Y, I'll write it up again, is A times E of X plus B. Alright, so we've got to identify what's our value of A and B here. This is our value of B because it's the constant term. This is our value of A because it's the coefficient of X. Okay, so that means our E of Y, our expected value of Y, is going to be 2,000 times E of X. So that is 2,000 times 1.96 plus 10,000. So what do we get when we do that? We got 3920, 13,920. Interpret. Okay? So X is the expected number of cases. Here we've got the variable Y is the amount of money he's going to earn. $10,000 plus 2,000 for each case. And so then E of Y is the expected amount of money each month. Done. Okay, so there's an application of it for you guys.